Hello viewers, last time we did about the factors affecting resistance and they were nature of the wire, length of the conductor, thickness and the temperature. So now today we are going to derive an expression related to resistance. So as we did, resistance is directly proportional to length. I told you as you increase the length, the number of collision will increase and ultimately what will happen? There would be more collisions and ultimately the resistance would be more. And yes, it was inversely proportional to area of cross section of a wire. It means that if we combine these two expressions, so it will become R proportional to L by A. And if you want to remove this proportionality sign, you have to put a constant. So equal to, let that constant be rho L by A. So this rho is said to be resistivity. And if you want to define resistivity, what are you going to do? Rho, you are going to keep it here only, A and L will go that side. So you will get this as your expression. Rho is equal to R A by L, where R is the resistance, A is the area of cross section and L is the length of the wire. So now if you want to write the units for rho, what you will write? So we know unit of R is ohm, area is meter square upon meter. This will cancel out, so ohm meter is the unit of rho. Now if you want to define what do you mean by 1 rho meter, so you will say that resistivity is said to be 1 ohm meter when a wire having area of cross section 1 meter square and length of 1 meter has a resistance of 1 ohm. So means whenever you define any SI unit with one value, you need to make all the variables which are related to that physical quantity to be 1. So here you have made rho 1 ohm meter. So for that you will write R, A and L to be 1. Right. Now after that we have a very important thing that they usually ask, does rho depends on the area or the length of the wire? You know, sometimes they ask you that you take a wire, you divide it in half twice, you make it double 4 times, will the resistivity change? And most of us think yes it do change, but you should remember that resistivity for a particular wire will always remain constant no matter you increase its length, decrease its length, increase the area, decrease the area, whatnot, right? So make sure that whenever they ask you, will resistivity depend if you change the length of the wire? No, it doesn't depend on the material, right? Sorry, it doesn't depend on the length or breadth of the material, but yes, it depends on the nature of the material. Nature of the material means, for example, if you take a copper wire, right, and on the other side you take silver wire, and suppose they ask you that you change the wire from copper to say silver, will the resistivity change? So yes, the resistivity will change because this value depends on the material that you are using, right? But if I say you take a copper wire and you make its length to be say from 4 meter to 8 meter, so will the resistivity change? So you will say no. So remember, until and unless you change the material, resistivity will not change, right? First thing. Second, resistivity also depends on the temperature. So till the time the temperature of whatever is your observation is constant, it will not change, right? So make sure resistivity for a given temperature depends only on the material, not on the length, not on the area, right? Okay, after that we have very important, things here related to this chapter. So this just now I have told you this thing. So expression is R is equal to rho L by A, and if you write the expression for rho, you will get it as R A by L. Just now I told you. And yes, rho is said to be resistivity or specific resistance. And just now we find the unit of this term also, which was ohm meter, right? And Abhi, I told you that it depends only on the characteristics property, means it will only depend on the kind of material that you are taking, and it is not going to depend on the length, breadth or whatnot, right? Now, yesterday we did that the reciprocal of resistance is conductance, right? Today because we have defined rho, so reciprocal of rho is called sigma. What is the sigma? The sigma is actually the resistivity is the rho value, and this value is your conductivity, right? So this is conductivity. So reciprocal of resistivity is conductivity, right? So how we will write that? I know formula for this rho is R A by L, right? Now if you want to define conductivity, you will do the reciprocal of it. Reciprocal means 1 by rho. If you are going to do 1 by rho, this whole thing will become reciprocal. So R L will go here, this thing. So this thing is conductivity is LAR. So this you have to remember. And also because the unit also could be asked, so resistivity unit was rho meter. So unit of conductivity would be ohm inverse, meter inverse, just the reciprocal. And we say this thing is Simon, written by capital S, per meter, right? Very important again. So this is given here in your book, right? And units are given. Instead of that we write Simon per meter. If you want to, if you don't want to write per ohm, you can write Simon. Now this part is very important, that is choice of the material of a wire, like how you will decide that which wire should be chosen for a particular apparatus, right? For example, if suppose you are using wire for connection purpose, so for connection purpose, like we use copper wire, so copper wire has got low resistance. Why it has got low resistance? So that electricity can easily pass through it. And I told you in the last video that electricity can easily pass if the resistance value is low, because electrons will have less opposition from the wire. So that is why we prefer copper, although you can use silver also, but yes, silver is very costly, so we are not going to use that. So after silver, the best is copper, right? So important. And yes, if you make wire to be thicker in size, right, so what will happen? Your resistance will decrease, because we have already done that resistance is inversely proportional to area. So if you are going to increase the area, resistance value will ultimately decrease, right? So that is why you must have seen when making or for the construction purpose, when you are putting ACs and all, so the wire that you put for AC, they are quite thicker compared to the other wires, like AC wire, geyser wire, they are quite thick. Just observe it around, you will find it very relatable to this topic, right? After that is second thing, that is resistance wire. If you are using a resistor, so if you are using a resistor usually is a device which has got very high value of resistance, and that should not change with the change in the temperature. So we usually use the alloys of manganese, constant. So remember, you have to know the names of the alloys, because you never know in the MCQ part, or otherwise also they do ask you for 1 mark that which material could be used in this particular case, so that there is no change in the resistor with increase in the temperature. So you should know these two alloys could be used. Next is a fuse wire. The fuse wire part is going to come in detail in the next chapter, that is electricity, household electricity, household circuit one. So but still you can remember here, fuse is a device, safety device, right? Means whenever there is excess of current, it is going to switch off itself, right? So in that particular device, we have a wire made up of lead and tin, which has got very low melting point. Why? Because if in case the current increases, what will happen? We know with the increase in the current, the resistance, the wire will get heated up because of the more number of collisions and all, and ultimately what will happen? The wire, because of the excess heat, it will melt. Fine. Now filament. For filament we use a tungsten wire, because it has got a very high melting point. And yes, this point is very important. Heating element. Heating element, you must have seen, we are using toaster, geyser, or heater also. When you switch on that device, that especially the heaters, there is a wire kind of thing, right? It becomes red in color when you switch it on. So basically it is made up of nichrome wire, right, which has got a very high resistance value. And ultimately when it has got high resistance, what will happen, it will generate more heat, and that is why it turns red in color, because of the high resistance and high heat generated, right. So make sure that you do this part very carefully. There are 5 points given under this topic, and definitely one question do come from this part. Either in MCQ it can come, or nowadays what board has started doing it, they have started putting 1 mark question in, like yes, write yes or no kind of thing, right, or just write the name. So I mean, they are becoming very specific with the question. So for being very specific, you should read each part of your chapter very carefully, so that from any part wherever they ask you, you know from where you have to write and from where you have to attempt, right. Next are the superconductors, the last topic for today. Superconductors are basically, as the name suggests, super means extraordinary. Extraordinary conductors. We know what are conductors, the ones which conduct electricity very, very easily, right? And if electricity is conducting easily, means that the resistance of that particular conductor is very low, because I told you resistance and current, they are inversely proportional to each other. So when you say superconductor, so the device will have almost zero resistance. Although we know that is not possible practically, that actually is not practical to say that the device can have zero resistance or infinite conductance. Why the word infinite has come, I'll tell you. Because we know resistance and conductance, they are inversely proportional. So let me interchange these two. C is 1 by R. So if this is 0, resistance is 0, 1 by 0 becomes infinity. Infinity means very, very high value of conductance, which is not at all possible, right. So but there are they have given some material which behaves nearly to superconductors at a given temperature. So make sure you remember the temperature also. Like for mercury below 4.2 Kelvin, this is very, very low temperature, it behaves as a superconductor. Lead below this value, niobium below this. So make sure that you remember the name along with the temperature. Just don't remember the names, do remember the temperatures as well, right. And that is all for today, right. So just revise with the previous part also, because then in the next video we are going to discuss few questions related to part A of the chapters that is being covered up.